This is your video for Variables and Patterns, Investigation 4.3. We will continue to make equivalent expressions, but this time we will be using the distributive property in order to accomplish that. So, as always, the first thing we want to look at is what our learning target is. So, our learning target for this one is to create expressions that are equal using the distributive property. Before you continue, you will want to grab two different colored pencils or highlighters or markers because we will need that coming up next. Typically, I would go on to the key vocabulary, but for this video, I want to actually do that last. I think it'll be more helpful for you to see the distributive property and see the two forms, expanded form and factored form, in practice. That's more helpful, I think, versus trying to define them first. So make sure you have your two colors before you continue with the video. Using any color that you want, the first thing that I want to do is label parts of the shape that you should see. You should see one more that's square and rectangular, and one is like inside of the rectangle. And the short side, I want to label as side A. And then the other side, B. And then the longer side, C. So side B is right here. And then C, oops, those are supposed to actually connect. C would be the rest of the length. So I want you to use your two colors to shade in. You don't have to be super neat about this, but shade in the smaller shape with one color and using an alternate color to shade in the bigger one. This is so you can see the two parts of the shape that we're dealing with. And this is going to help show you visually what it is that the distributive property accomplishes and why it works. Okay, so I'm going to go back to my black ink pen. All right, distributive property. First thing is inside. If you were to find the area of the shape with side A and side B, you would do that by doing A times B. And if you were to find the area of what I shaded green, you would share this side right here, which is still side A, and then you would use the length, which is side C. So this would be A times C. And at this point, you should notice that both share the variable A because they both shared the side length that was A. So those two sides right there. If I wanted to find the area of the entire shape, then I would need to add together. So let's say I wanted to find this and then this whole bottom length. Well, there's two ways that I could do it to find the area of the whole larger shape. The first way would be to add together the two smaller pieces. So I would have A times B, and I would need to add to that A times C. So these would be two pieces that I would put together. Well, the second way that I could do it, which some might find a little faster, would be to take the one side A and multiply that by this bottom right here. And you find the length of the bottom by doing B plus C. These two right here are equivalent expressions, and they show how the distributive property works, because in this one expression that's underneath the shape, you can see that both of them share an A. Well, in the other one, I took the A and put it on the outside, and then it would be shared with the B and shared with the C. So distributive property is all about sharing what's on the outside of the parentheses with anything that's on the inside. So that's just a very quick look at distributive property. I'm going to show you a few examples, and this is where we get into the vocab, the factored form and the expanded form. So factored form, you can see where something is outside the parentheses, and our goal is then to share that. Another way to say that is to distribute that. That's why it's called the distributive property. So here we have a variable and we have a number that is outside, and just like in the above example, when the A was outside, we need to share it with what's on the inside. So the X is going to be shared with the 5 and shared with the 6. And it's shared through multiplication, because anytime a number or a variable is right next to a parenthesis, that means multiplication in math. So you could also write little dots if you wanted to by those arrows, just to show that you're going to multiply. So then I would do X times 5. The addition sign stays, and then I share the X with the 6. So this first part is factored. This second part is expanded, and it's expanded because it's longer, so that's what it means to expand, to stretch out. So let's go on to the next example, where I have 7 on the outside. 7 needs to be shared with the 4, and 7 needs to be shared with the 3x. And again, every time I share, I multiply. It means I'm going to have 7 times 4. And here it's a little different because I have a subtraction sign. So now I'm going to do subtract 7 times 3x. Now, we've got factored and we have expanded. Now in this case, I could go one step further and I could actually simplify, because I can solve 7 times 4. So 7 times 4, I could simplify this to be 28 minus, and then I can multiply 7 times 3, so I would have 21x. Right now, I'm not as concerned with the simplifying part right here, but I want you to be able to begin to see how we share what's on the outside with what's on the inside, or we distribute. All right, when we start with expanded and go to factored, what we're looking for here is looking for what the two pieces share. So in our first expression, they both share the variable k. That means that that part is going to be on the outside of the parenthesis. Then I take the pieces that are left over, the 3, the 6, and my operation, the plus sign. And I put those inside the parenthesis, 3 plus 6. Now I have gone from expanded or stretched out to factored form. And hopefully you can see that if I were to undo that, the k would be shared with the 3, and the k would be shared with the 6, which would give me my expanded form right back. In the next example, they both share, not the variable this time, because one is x and one is h. They both share the number 2. So that means instead of having a variable outside the parenthesis, I'm going to have a number. So I'm going to have the number 2 outside, and inside the parenthesis I'll have the pieces that are left. X, the plus sign, and the variable h. And once again, hopefully you could see that if I were to distribute the 2, it would give me 2x, and if I were to distribute the 2 to the h, it would give me 2h, which would give me the expanded form right back. So this is kind of a brief look at the distributive property. Now let's go back up to the top and define some of our key vocabulary terms a little bit. All right, distributive property is one of those properties that even though it is used probably most frequently in math, it is probably one of those properties or mathematical tools that we use that is also very difficult to describe in words. So I made it probably as simplified as I could, just by saying that it is used most frequently in math. And what it does is it allows us to multiply what's outside the parentheses, whether that be a number or a variable, and you multiply that with the terms or the pieces that are inside. So that means that it could be a number inside the parenthesis or variables or a combination. And hopefully you were able to see that. But it is, even if you look up definitions, they get very wordy, and they use a lot of other math vocab in the description. So distributive property is not one of those things that I will ever ask you to define. I will ask you to be able to use it. So where you would show me that you can go from expanded to factored, or from factored to expanded. With this distributive property and looking at the two ways of the pieces of it, so expanded and factored, those are also very difficult to put into words to define. So what I'm going to do is I'm going to use all variables, very similar to down here where I showed you first. So I'm going to use A, B, and C just like in the picture. So expanded form is going to look, see if I can scroll here, like this. So you can see where that came from. So expanded form is going to be A times B plus A times C. Where you can see that it's stretched out. And then factored form is pulling out or looking for the part that they both share, which in this case is the A, and then putting the other pieces in parentheses, which is B plus C. So again, that's not much of a definition. And just like with distributive property, I will never ask you to define expanded or factored. What I would do would be to give you examples down here at the bottom, where I would ask you, in this case, to go from factored and you would give me the expanded form, or vice versa, where I give you expanded and I would expect you to be able to turn it into factored. But you do have to be familiar with the vocab words that are up here, and be able to know in class that when I talk about distributive or when I use the terms expanded or factored, that you know what I'm talking about. That's why I put them under key vocabulary. So we will continue to practice using this in class to be able to create equivalent expressions.